this? You have all okay, excellent. Okay, good morning, guys. Again, welcome with the one goal, mastering Databricks, uh, which is very popular. I've been working for Databricks last 6 years. Recently, I came full time onto these trainings and building education company and supporting Frisco Analytics, who are partners for Databricks, who are working to get good projects. Hope by January, February. Larry is working for Frisco Analytics. How are things? Projects pipeline looks good. Hope you.
Hi. Yeah, Srini.
Okay, excellent, excellent. So I'll connect all of you to Frisco Analytics. Lahari will help you in the Java opportunities. But first of all, we should be ready, guys. So think the fundamentals, basics, how things work. Don't just jump into technical things. I want you to balance between what exactly this challenge the thinking every time why it is like that. If we have that thinking, you really will be very successful in this career. So as we discussed yesterday, every company is becoming a data and AI company. Every company. Vishruth, any opposition for that statement? Every company is becoming data and AI company. To bring to value edge to their growth, their survival. Otherwise, they cannot compete. What does it mean when the data is harnessed? There is intelligence in the data. So who are the customers about to leave? What customers are potentially very high net worth, who has long term value, who can support? What customers have a lot of concerns about our products, who are regularly paying, who are not paying? So, who have pain points, what products they're buying. So, all these are very relevant questions for the companies. So, dealing with customers is very important. Every company cannot survive, no company can survive without customers. So, that's a very good use case. Anything related to the customer, intelligence about the customers, reports about the customers, so that that intelligence your company, the company you are going to serve, should have. So for that, they need a good data and AI platforms. They need a good data and AI platforms. That's the reason they invest in these platforms. That is the reason they don't mind to spend a lot of money on these platforms. We think it is a lot of the money, but the ROI is great. Return on investment is good. If they invest million, the return on investment is 3 million. If they invest 2 million, the return on investment will be 4 million. So since the return on investment is big, they don't hesitate to invest in these products. That is the reason. They don't want to spend so much time on building these things, which would be very expensive and takes a lot of time from the people. Security, putting nuts and bolts and all these things. That's why these platforms like Databricks and Snowflake have become popular because the in-house building of all those, they can be built. They can be built. It is not that they cannot. Nena, even we can build a house in Hyderabad or in US. It is not that it cannot be done. But can we do efficiently in a time frame, efficiently with a good standards, with the less time? So all those questions comes into the picture. That's why, oh, no, I have a job. In the weekend I need to spend time with my family. I need quality of time. I don't worry. I will give to Lennar or some builder. They will pay money. They will take care of it. So that's how people think. Correct, Naina? Yes or no? Lahari? Yes or no?
Yes.
Yes.
That's how you think. Even that's how the companies think. It is not that companies cannot build. A lot of people think, oh, why we need Databricks? Why can't we build? Hey, build it. Build it. Then that becomes your, suppose your company is AT&T, Lahari, suppose your company is Nike, assume. What is your, as a Nike, a Nike job of, suppose you are working for Nike, you and Nike goals, what is the goals of Nike? Come on, come on.
Mm, different types of shoes or products.
Exactly, to sell great products, right? To continue, keep that experience of Nike. Just do it. That emotional thing, right?
Yeah.
So your goal is towards that. So all other things you should minimize. So if your whole goal becomes to build a platform, which we are not good, is some specialist company like Databricks is good, or Snowflake is good. You have hundreds of engineers who build the security, etc. You take the platform from them, start using it. Start using it. Build whatever they have built, right? So you don't build the platform, then your whole company, a lot of people will be working on building the platform. So the main goal of Nike, when they hire you, even though you are a technology professional, Nike hired you to achieve the goals of the Nike. The goals of the Nike can be achieved if you can bring tools efficiently. Not you make the tools for them. If you start building, then Nike becomes a software company. Nike becomes a technology, of course, Nike is a technology company, but Nike becomes a data analytics company. Nike is not a data analytics company. Nike is a shoe company with a great emotional customer basis. Larry, agree with me or disagree? You are free to disagree.
No, 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 I completely agree, Shane.
Exactly. That's how the companies think, guys. That's how the company is saying. Oh, they have just job means don't think they will just go and do whatever. They are not allowed to do whatever they think. So every company has to strategically go, strategical. Otherwise, they fall into, you know, deep into ocean and they can't come out. It's a competition. Everyone has a competition. Subhash, do you agree? Every company has a competition,
Yeah,
including Google.
yeah,
Agree?
yeah, I agree.
Do you know Sundar Pichai is in very he is not sleeping well nowadays? Do you know?
Yeah, a
Have you
lot of competition for him right now.
exactly from OpenAI? Have you ever thought Google will have a competition? Have you ever thought a few years back? There is no way, right? We haven't thought. Oh, Google is dominating. It is leading. Everyone go for search. But now, so much competition from artificial intelligence companies. Now, I'm hardly searching Google. I'm searching only ChatGPT. A lot of people, for that matter, see the answers. So that is the biggest revenue for them. They're losing it. So that's why they are working hard. So like that, even every individual, we all have competition. Everyone want a good job in data analytics. Everyone want a IT job. Everyone putting effort. That's why we are putting a methodical effort with experts like Harun and Shiva, who have decade plus experience. We're collaborating. I can do this alone, but I'm not doing alone. I need experts. That's why we bought Harun and Shiva, who have extensive experience. So that's why you have the best support. I want you to understand why these data and AI systems are growing, not just technically. It is very important to understand the business goals of a company. So business goals turns into technical goals, not the technical goals becomes a business goals. So business goals, business value is very, very important. Naina, Lahari, Razu, Vishwata, Itesh, you always should think whatever I am doing, how much value it is adding to the company, how much how much business value it is adding the company. Whatever I'm doing, where it is getting impacted. So not only in the training, every time when you go to a company, also you should always think, hey, what is the use case? I am building a pipeline. This pipeline is used for what business use case? This is used for what machine learning related work. So a lot of people don't think that. They just do this. Oh, I have done my work. I don't care. What is going on. They don't even know this what this company is. They think, oh, my company is some railroad company. I don't know what they do. I'm just building my data. Those days are gone. Your business value is understanding business value is very, very important. So, having said that, today we're going to quickly see again the Databricks architecture a little bit. Then we will run some code. I'll show you how powerful is Databricks Spark to do the ETLs. I'll give an intro, a little bit hands-on, then Harun and Shiva will take it forward. Is it clear for today, Hitesh, the agenda?
Yes, sir. Yes, it's clear.
Excellent. Very good. So, everyone, let us see. I have another slides. I'll try to share these slides. Everyone, let us see. Databricks call their platform as data intelligence platform. So first of all, please understand, Databricks is a platform. Databricks is not a solution. It is a platform. It handles a lot of data. The idea is this is mainly used for data intelligence. Data intelligence means there are two things, data and AI. Data and AI. Data reports, even machine learning related stuff. So their aim is to bring data and AI capabilities for all companies. All companies. That is their goal. The platform is this one. It looks like this. You need to have this mental picture. So they call it as an open data lake. So it means you can put in the Databricks platform. I'll show you how the Databricks platform looks like before I show you. To unify data, it means you can put structured data, semi-structured data, unstructured data. Structured data means data in the tables, Parquet, what do you call it? JSON format. Semi-structured is some CSV files, some other XML files, even though they have structure, but they are not fully like a table. Unstructured data, Lahari, Naina, Subhashini, unstructured data means even PDF files, like a free text files, images, audio files, those unstructured data. So any data, anything with data is it can be stored, unified data. So they are stored in a open data lake. In the sense, if they say open data lake, is either Delta. Delta is a open source. Even they have Unity catalog. where you can securely store data in the mount point. Just like you are storing data in your laptop, Subhashini, in your laptop, you store in a structure, right? Even though the folders are structured, a folder, you organize the data, but you can keep your photos, your audios or videos or Zoom recordings or even Excel files, anything you can store just like that. So instead of storing in laptop, in a cloud environment, in a securely, a structured way, you can store. That is unified data, any data. All the data should be governed properly. Unified governance means some structure and who has access. Who has access? A certain group of people need to have access. That type of things. There is a governance using a software tool called Unity Catalog. Unity Catalog. Unity Catalog. So storage and governance is very important. First of all, that's how Unity visualize this. Okay, but how you get this data? How you get this data? Naina, Subhashini, how you get this data? You need to do ETL. Look here, this is where it is. ETL. Extract, transform, and load into this. It means you need to get from somewhere. You need to extract. You need to transform. You need to load into this. That is the ETL. ETL. When you do the ETL, you can do batch and real time. That's why it is ETL and real time analytics. So you can bring the batch data, you can bring the real time data. Then you can do analytics on it. Analytics on it. Analytics means you can do business intelligence. It means you can use some front end tools like Tableau, Power BI, or SQL. You can do that intelligence. So for business intelligence, you can do analytics. You can do analytics. Actually, the word analytics here, business intelligence, these two goes together. These two goes together. Please note this point. Okay. Apart from analytics, apart from intelligence, you can also do AI and data science. AI and data science. All this functionality, this business intelligence, rather let's put it, business intelligence, that querying part, analytics part, is supported by the concepts of data warehousing. Concepts of data warehousing. Subhashini, what are the concepts of data warehousing? It means when you're storing the data, especially the structured data, you need to store like a warehouse. A warehouse means, you know, you put various goods somewhere, like data warehouse. It means you store the data into tables, and there are some relations for them. They're not like a relational database, but OLAP, online analytical processing database. It means they store the data in tables, different formats, in the sense facts and dimensions, that type of modeling techniques are there. We'll be discussing in the class. So please note this: unified data governance, the ETL, and to do the business intelligence, you need data warehousing capabilities. This one, two, three goes together. Please note, understand. This ETL is to get the data. Then you store in the data warehousing. Then you do the lot of report. That's why you see it shows the dashboard. So these three goes together. These three goes together. So this helps the companies for a lot of business intelligence. And apart from that, company do some advanced data intelligence techniques like using machine learning and AI. So there will be some teams who will be doing this. You'll be supporting them. You'll be supporting. So your goal is to make sure proper data is stored using ETL and real time. Proper governance is there with Unity Catalog. And data is structured in data warehousing so that the data is available for reporting and business intelligence needs. That is the main goal. Apart from that, your goal is to support AI and data science teams, AI and data science teams, so that they will do advanced analytics, advanced analytics. But all this can be supported with jobs and tasks. They should be orchestrated means scheduled. You need to schedule the jobs, when to run, when to not run, what happens when you run shall you run this job when this job fails or not. All these things you'll be doing the orchestration. This one diagram should be in your mind when you think of Databricks. Any questions on this? How does one picture looks? Picture speaks better than words. Lahari, Subhash,
Yeah, it's
just
clear, Srini.
just to start, just to start, you know, just to start. See, when you go and buy a home, you go and see the house first, look like this. Okay, hey, how the front look like, how the you don't go to too many details, but hey, how it looks like that. So I'm just giving a big picture out of it.
Srini,
Subhash, yeah.
one question, Srini. This unified data, right? Uh,
Mhm.
it is like a combination of all that, like structured, unstructured, and like a semi-structured data put together and governed, or is it like you first structure the data and then you add in that pool? I just have a doubt on that.
But that's a good question. Yeah, first of all, they will not be mixed. First of all,
Okay.
you may have it's all ultimately they're on folders only under the hood. Actually, there are folders.
Okay.
Okay, some folders, some sales folders, marketing folders, some operational folders. Say take the marketing folders, subfolders, campaigns, that thing, that thing. So the data related to that will be there in the Parquet format, very efficient format.
Okay.
So then there will be tables built on top of it so that the data can be accessed. And those tables will have access controls, role-based access controls. That's about structured data.
Okay.
Then say you have some images about marketing. Oh, since there are images about marketing, instead of putting in the tables, they might store in a different folder as images, right? But since again they can't be accessed as a table, right, Subhashin, because they are images. Okay, the goal is first of all security. Who access this? Any nobody can just go and open them. So security. The which groups can have this security? So, so where in which folders they are, like volumes. Instead of putting in a table format, you store them as a volumes. But again, those volumes are governed. So, like that, think of it as a data lake as a big laptop, but in the cloud, right? So, in that laptop also, we just how we organize our folders. The company, you will work with some teams who will help you to organize that data, how they should be structured, all these things. Make sense?
Yeah, I got it, Srini. Thank you.
Okay. Hitesh, does that give you a good picture, high level?
Yes.
Okay. Vishal,
And
let's go to one more slide before we get into the system. Database data intelligence platform data and AI for all again. Okay. This platform you have seen as a picture. But generally, these are the words people also talk. Again, let's relate what it is. Okay. See, data engineering guys, data engineering. Data engineers, what they do? Here. They do ETL mainly. They do ETL and put the unified data. And they do governance, right? Here you see data governance. So it means these two, and even this one. See, real-time streaming. Real-time streaming. That's why if you see this type of words, try to relate them. Relating them really helps. Shiva remember things very well. He does research where this lot of Medium articles are there, where the Spark helpful notebooks are there. He will share a lot of code for you along with Haran. So data engineering, data governance, and real-time streaming. If you see these type of words, you go here in this picture. Oh, okay. Data engineering, real-time streaming is nothing but batch and ETL. And load it here, and there is a governance. That's it. Data engineering, real-time streaming, data governance. These three will cover this one, this one, this one. Excellent. Next, guys. What is that? Data warehousing. Data warehousing. See here, data warehousing. And these two go together. Once you have a data warehousing, you start doing queries on top of it. Business intelligence, SQL. These two covers this. Next here, artificial intelligence and data science. This covers this one. AI and data science covers this one. In this picture, it is not there. Two other words, data sharing and marketplace. Data sharing means your company, you have a great platform. Can we share some data to partners, some external teams? Of course, you can send the data always, but without sending, can you share it? Can you share it temporarily? There are some techniques in data governance called data sharing. You can share certain one table as an API, so that they can pull it. Instead of you sending the data, they can pull it. And after some time, you can stop. So that type of thing is a data sharing. So don't worry about this right now. Marketplace is this platform also supports. You don't have to know it a lot. Marketplace means some third-party teams can give some supporting data and models or AI models where other companies can use in Databricks. So Databricks has a marketplace where people can sell some code, some data, some models. Some companies can sell some assets, data and AI assets. They may share free, some they sell it, some they negotiate the price. So people go to the marketplace and look, just like we go to Amazon marketplace, buy books, etc. They go to Databricks marketplace and see, maybe our company needs this data, maybe some survey, or weather data, or some other Wall Street data, some other political data, some insights about some other company, competitive data. They can buy that and dump the data into platform and can able to work. Awesome. Having got understood this, I want everyone go to sign up a free version of Databricks. So go to Google Databricks Community Edition login. Can everyone on your computer search this in Google and go to this community edition? You don't have login. There is a button called sign up. Everyone, sign up. Click this sign up. You get this screen. Sign up. Use your first name, last name, email. Try to give your Gmail or any of your company email. Shiva, is it taking Gmails nowadays? Let's hope. If not, give any company name. Try with Google. I think they started.
Yeah, I think so, Srini. Yeah, I'm still using my work email, but yeah.
Yeah. Then let me do that. Google search Databricks Community Edition at gmail.com. Company Google, title, architect, something you put. Phone optional, can remove. Country United States. What do you want to build and run Databricks? Say learning and certification. Okay, whatever it is. Then we say continue. See, here, be careful. Don't use any of those. Hold on. Professional use. Pick your cloud provider. You will need admin access to your this one. Instead, don't
You
use
still
this.
need to select that Azure there and then click on started community edition.
Oh, do we need to? I
Yeah.
don't think we need to do anything here. If we
No,
use this, this
it
should be.
selects AWS by default there.
Really? I don't think
That's
so. Okay, select this. Harun is suggesting use the Microsoft Azure. Don't use the red one. Use this. Get started with Community Edition. Okay, just started with Community Edition. Okay, please solve the puzzle. We know you're a real person. Start puzzle. Now, what is this? Use the arrows to rotate the object. You want to match this angle. Or this one. Match this angle. Okay, read this. It's done. Verification is done. I'll go and check my email where I will have access. Everyone do this. Then you will get a link. You will log into this, a community edition like this. I already have. I have even two already. Something like that. You will get into log it. I want everyone to log into this. Everyone. When you're done, you put a thumbs up like this, When you done, how you put the thumbs up. Where is this? I don't see. Where is the? Okay, put thumbs up like this. If you have done that. Everyone. Super. Hitesh done that. I want everyone to do this. Razu, hope you are doing. Lahari, are you doing that? Subhashini.
Yeah.
Naina. Yeah. Click.
I'm waiting for this verification email.
Phishing email? Oh, you're waiting for the email?
Yes.
Okay. Let it come. Let it come. So after that, you click that, you log into the system like this. You log into the system like this. You will see Databricks, new workspace, recent, search, catalog, Windows, compute. Compute is important. So you'll see something like this, compute. Of course, you don't see this now. So in Databricks, you can create a new notebook. Notebook means where you write your code. Where you write your code. But you need to run your notebook. These two are important. New notebook and compute. Compute is where you run your code. You need a machine to run it. This is a web-based UI. They will give you machines. So you can create a compute. You can create a compute. Whoever done it, log into the system. Once you log into it, once you thumbs up, once you log into the system, take a couple of minutes. Harun, let them take a couple of minutes. It's important. They need to do it. Correct? Very good.
Yeah, yes, Srini.
Let's Naina, thumbs up. Awesome. Okay.
Yeah,
We should this thumbs up. Good job. Good job, guys. Good job. So you log into it, you will see the screens like this. You see the Databricks. This is a community edition. It will have most of the features. Some features will not be there. For now, don't worry. So you see a new button, Hitesh. You see a new button. You'll see a notebook. Then you will see another, which is a compute. New notebook. Notebook is where you write the code. Compute is where you run your code. Where you run your code. Notebook is where you write your code. Compute is where you run your code. So, everyone, you go to your code, compute, you create a compute. Say, today is October, whatever you call anything, any name, October 20th cluster. See here, it's giving a new compute name. It says Databricks runtime version. Runtime. See here, it has 12.2 LTS long-term support. Scala and Spark. It's a version of Spark version. Don't worry about Scala. You can either use any LTS, either 15.4 or 14.3. I'm okay. These two you can use. Even you can keep 12.2 also. That 14.3 I used. Please note, they are saying a free 15 gig memory as a community edition user. Your compute will automatically terminate after an ideal period of 1 or 2 hours. So if you are not using it, your compute will be terminated. Okay, don't worry about this. This is Spark, some configuration. They put some configuration here, Spark configuration. They put some environment variables here. So how that, where is it? Why it is not? Give me 1 second. Okay. Then you see create compute. Click this create compute. Create compute. Now go to see it is starting. It is starting up one node. They will give one node. One node. One node means they will give you one machine. In the real job, you will have multiple machines. But first try to work on one machine. And one machine has a 2 cores. That machine have 2 cores. It means multi-core machines. Multi-core machines. It is not a single core. Single core means single processors, 2 processors will be there. So if you go to again compute, I already have one cluster before. I'm not using it. I think they don't allow to restart. So I created a new, the cluster is static. So it means a computing machine you are creating. You will use that machine to run your code. So let it run. It takes a minute to start doing. I want everyone to do that. So having done that compute, now I'll go to new notebook. New notebook. When I say notebook, so you'll get something like this. You'll get a word C Python. It means you can write your code here. You can write your Python, PySpark code. I'll just put a comment. You can write your Python and PySpark code here. So you have the name of the notebook. This is the name. You can write a good name. October 20th, my first notebook. Something like this. You'll be writing. So you can write the code here. This is the name of the notebook. So you'll use this new notebook. You write your code here, but you'll run your code here. Here, cluster. The one you created is still starting. See here, if I use that, see here, it is starting. It is starting. It takes up some time. Once it started, it will be there an hour. Then we can start writing the code here. This is where you start writing the code. First, I want everyone to do that. Everyone to do that. So create a compute. Just click a new notebook. I want everyone to do this. Then we'll show you. I'll show you how to put some code. Then we'll have and Harun will take over and show you a lot of code. These first two steps are important. You logged into Databricks. You created a compute, which is still running. Then you are going to new notebook you created. You can have a notebook name. This is where you'll be writing code. You don't have to write. If you want to put, you can put some comment. You can connect to this cluster. So it is very simple. You are writing your code here. You'll be running your code on the cluster. Write your code on the notebook. Run your code on the computer. Write your code on the notebook. Run your code on the cluster or compute cluster. Okay, let it run. I have my first notebook. If you're done up to this, thumbs up. If you're done that, put a thumbs up. Put a thumbs up. Naina, good job. Hitesh, good job. Super. Now we'll do simple experiment. Somebody, I want Vishwat or Naina to share their screen. You can clear all your browser windows. Anything you don't want to share. Then you guys are going to run some code. Some sample code. Just to get the hang of it. This exercise is to get the hang of it. First, if you get the hang of it, then you love what Harun is going to do, what Shiva is going to do for you. Everything is hands-on. We want you to do hands-on. Naina or Vishwat, anyone? Yeah, Naina is ready to share. Ready to share her Databricks window. Excellent. Awesome. So let's see. Notebook. Very good. You can name the notebook. Left corner. Yeah, you put it some name, whatever you want. That's your choice. You can put a name, whatever the name, whatever you like. Whatever the name, whatever you like. Very good. Excellent. So can you connect your notebook to a cluster? Right side is top is there. Connect. Right side top. Yeah, connect your cluster. Can you put to this cluster? Yeah, you can touch that. Yeah. So it is still starting. Okay, let it start. It will come. Meanwhile, I'll share one small code on the chat. Try to copy that. We'll try to understand what it is doing. First copy that. Copy that code. Copy that code. Before even you copy that, uh, just write something like this. Just simple Python code. Okay. Name is equal to name. A variable, a Python variable is equal to name is equal to no, just say name. Name is a variable. Name is a variable is equal to put any of our classmate name, not your name.
Yeah.
Anyone in this screen you say, either Lahari or Subhashini, Razu, whoever it is. Put it in the quotation because it's a string.
String that, yes.
Exactly. Put in a quotation. Very good. A quotation end. Okay. Okay. So this is what does it mean in Python way? A variable name is equal to a string Lahari. String. So once that cluster is ready, it is still starting because this is a community edition. A lot of people use. When it starts, you get a green. Okay. Meanwhile, go to another cell. Click a. What is that? Where is that? Shift enter to run. Shift control H to see. There is a plus button. Okay. You just go to right side. You see three dots. Right side. Same cell. Same cell.
Same son.
Same cell. You see Python in the cell.
Yeah,
You
sir.
see Python after that. Yeah. Click
Wait.
that. You see there is a uh, add cell below. Add cell below. Okay. Yeah. So it added another cell. So
Yes.
this time print it. Print bracket begin variable name. Variable name. Right. Just put the name. So once the cluster starts, we'll run this both. So first one is name. Next one is stored in first one you stored the variable name whose values a string Lahari, and then you are printing that name in the second command. Meanwhile, put another cell. Can you go to repeat the same?
So,
Put repeat.
so
Yeah.
Srini, you can hover below the box, and it will actually pop up to add a new cell also.
Okay, that's good. Can you? Where is that? They moved it.
It's right here. So if you hover a little bit over there with
Can
your
you bring
mouse,
the cell there? You'll
yeah, there you go.
click
So yeah,
code. Yeah.
yeah.
Awesome.
Okay, sir.
Click that also. Yeah. Great, Shiva. Awesome. You're a great helper. Okay, now you see right side, your cluster is ready. October 10th, your cluster is ready, green. So
Yes.
you're good to run. So now go to your first cell. Click that arrow. There is a left side arrow. That run cell. Click that. Say allow. No to allow. You can say allow. It's not a big deal. So let it run. It's waiting. First time it takes a little bit time. So your cluster is ready. Your notebook, that command, it ran. Okay,
Yes.
next line also you run. Yeah. Okay. You see?
Same Lahori. Yes, sir.
Okay. Good job. Good job. Everyone do this. Everyone do this. Everyone do this. Put thumbs up. Put thumbs up. Good job, Nana. Put thumbs up. Hitesh, Vishrut, Subhashini. Everyone do it. Create a notebook. Vishnu thumbs up, Subhashni thumbs up, Lahari thumbs up. Awesome. Awesome, guys. Awesome. Okay. Now, Naina. So I
Yes,
shared something on the chat. Can you copy? Let me paste again.
this one, sir.
Yeah.
Learning DF. Yeah.
Yeah, learning DF. So let's see. Just copy that. Don't run for a while. Just try to understand what it is. So lending DF is a variable, a left side lending, some lending related. DF is kind of a data frame. It's a variable basically. Is equal to Spark. You are using a Spark, which is a Python related Spark. Dot you're reading dot format. What type of format of the file you are reading? A Parquet format you are reading. From where you are reading? Load. You are using load. That is a path. That is a full path. What is that? DBFS, Databricks file system. Databricks. There is a folder called Databricks datasets. Under that, there is a folder called samples. Under that, there is a folder called Landing Club. Under that, there is a folder called Parquet. Somebody told you, hey, there is a Parquet files under DBFS Databricks samples Landing Club Parquet. That information, assume you know. Shiva or Harun has told you. Okay, you are loading the data. That format is Parquet, and you're reading that using Spark. So when you do that, that particular data will be stored in the variable lending DF. That is the idea. You get the good hang of it after you run it. Everyone, or first, Naina, let's run. Naina, yeah, run
Yes.
it. Run it. It might take some time because it's related to data. Everyone, take the copy. I want everyone to run that. Put in a, very good. You see, it completed. It just now it said, try to expand that below. It says lending DF PySpark data frame, right? There is an
Yes.
arrow below.
Mhm.
Little more,
This one,
little.
sir?
No, next one.
Yeah.
Yeah,
Yes.
yeah, yeah, awesome. Click that. Very good, Shiva. See here, wow, it read in one line, it read that file, and it is a Parquet format. Parquet is a very efficient way of reading it. It will have schema also. It has so many fields. Each field has a type. Subhashni, each field has a type. There are so much of data. So we would like to see it as a table format. Let's go to next line. Go to next line. So just say display, not print. Yeah, Lahari, display. You can ask the question.
So,
Display.
after logging into the community edition, we haven't loaded any data sets yet, right? So, uh, how did we get this even after loading? Like, we don't have any data set in our system. So, where can we see the original file?
That is a good question, Lahari. So the assumption is you have not loaded. Maybe somebody has loaded already, right? Got it.
Okay, so it was already there in the
Oh,
community
yeah.
edition.
These
Okay,
are
got
in
it.
community.
Samples.
They want
Basically,
to
it's
reduce
a
the
repository already existing in the Databricks that you are accessing.
They
Okay,
give
okay.
some sample for students' practices, etc. Display that variable, which is that lending DF. Let display bracket begin lending DF. Bracket lending DF. Yeah, you can enter there. You see that variable. So run it. Run it. You just read it. You read it. But usually, Lahari also, if you see, though that is just data we will not call it as a loaded data. It is just placed in the DBFS. They are placeholders. So usually in the company also, marketing data, sales data, they will load. Somebody will load into, I will not say load, somebody was put into the raw zone. They make it available somewhere. But that is where you start. You start reading it, then you start transforming it, then you load again, actually. That's what when you
Okay.
say extract is nothing but read. It means to read, somebody should have placed it. Right? You don't go to the systems and read. Instead, they will somebody already put it in a folders. But you still read, but you can do transformations, then you load again. That is the what really is the loading part, actually. Okay. Okay.
So can we like
Yeah.
instead of without writing the code, can we see where those files are, like, in
Yes.
the right panel we
Yes.
have workspace recent data.
Yes, we can do that. We will go there first.
Okay.
Let's see. Okay. Okay. This is not a grid data. Some columns are empty. Some columns are is there. Maybe a lot of null columns are there. But it's okay. At least you have learned. Hey, you just read and you displayed it with one line of the code. Subhashni, see the power of what do you call it? The Spark. With one line of code, you are able to read, you are able to write. Let us see. I will give you one more command. I want you everyone to do this. Everyone to do this. This time a JSON format. So everyone. Okay. This time everyone. Naina, you'll be
Yes.
still doing it and others will be doing it.
Okay.
Okay, copy it, paste, try to understand. Go to another cell. Go to another cell. You just scroll down, put a, yeah, go to, yeah, another, yeah, put a, hover it. Thanks, Shiva. That's a good input. This is a New York taxi data, spark.read.format. It is a JSON format this time. It is not a Parquet format. They're using a load command. Again, still, Lahari, your question valid. So assume somebody told you that data is there in that DBFS, Databricks datasets, New York taxi data sample JSON. But I will show you how to even navigate to that folder. It is nothing but a file system, correct? Just like your Windows file system, what you call your Unix file system, you can navigate. You can navigate. You can go and see what files exist, all those things. You have all the ability, assuming admin give you access. So, Naina, you're going to run this.
Yeah,
I,
sir.
I want everyone to run this and display this data. But this time, please note, this is a JSON data. JSON data. Earlier, you loaded Parquet data. This time, it is a JSON data. It doesn't matter. JSON is nothing but key value pairs. So it has a structure. It's a semi structure, but when you read it, it becomes a structure. So Harun will teach you how, from basics, how a JSON looks like. Parquet is a columnar. You can't read it with the human readable. It's a machine readable, but it is very compressed columnar data. Then other format, generally JSON and Parquet. Other format is even Delta format. There is another format is called Delta format. Delta format is nothing but almost like a Parquet format, but only thing is a little bit of difference will be there. I'll share that also. Delta format. Delta format. D. Okay. I'm giving one more command before you can. Meanwhile, you can put another cell, Naina.
Yes, sir.
You can display even the data. After you finish, it runs one cell by one cell.
Okay, sir.
Display. Yeah, the first one is done already. Display NYC taxi data. Display New York. You can use the bracket parenthesis. Display NYC taxi data. Just run that. Let's see the data. Okay. Then wonderful, right?
Yes, sir.
One line you're able to
It
read.
is. Yeah.
One line you can display. You can able to have a data frame. Think of you can able to load this without even you can save it in another as a table. So once you save, you are persisting. You are persisting a table. Then you can even query that table directly. Right now, it is not in a table format. Only programmatically, it is there in the file format in the first. When you read, you got a data frame. Data frame, even though it looks like a table, it is not stored as a table. It is not a persisted as a table, Larry. It's a programmatic structure. What you are seeing is that. So you can able to save it in a as a table in a schema. So for that you will be needing a schema. First you need a schema, then you can able to write it. Let me give you some commands so that you can you displayed your taxi data. So I am giving you a simple command where you can create a schema first of all. So before you write it somewhere, see there is another command you see I'm giving you, Naina.
This one, sir.
Paste it this time, everyone. So if you see, it starts with percentage SQL. When you put percentage SQL, see right side, the Python has changed to SQL.
Yes, sir.
Exactly. It means these notebooks, you can switch from Python to SQL. Even there is some other language called Scala, which is not popular in the industry. But so what you're doing is you're creating a database because your goal is to store this as a table. So you want to persist it. So a table exists in a database. First, you need to create a database. So you can run that.
Yes, sir.
You can run that. When it run, it says it created. It just said okay. Now go left side. Go to catalog. Left side. Left menu. You see, uh, far left. Yeah, catalog. You see, there is a default in Explore. So Explore is a database you created just now, Naina. If you click that, there are no tables. Go back to your notebook again. This time, go back to your notebook. Yeah, go to another cell. Just the same, copy the earlier command. Instead of Explore, you type something. October, otherwise says some sales, says something. Same thing. Create database sales. Or you copy and paste. The same thing, copy and paste. Instead of Explore, use the sales. Same thing. Yeah. Instead of Explore, create database, use the sales. It means you're creating a sales database. Yeah, run that. Go and see in the catalog. You see, there is
Yes.
it means these are the containers. Subhashini, you know that a database means a database can have tables. A database can have tables. So your company, you need to organize your data into this one, databases. Okay. Next, we are going to write whatever that New York taxi data. into Explore database. How you will be saving? You'll be saving as a table. Give me 1 second. Give me 1 second. It might take a little bit. Okay. One simple command. This time. Okay. Yeah. So you have NYC taxi data, which is a Python variable. You go to another cell. Yeah. What you are doing, you see, Naina? Subhashini? Lahari? What Naina is doing? She's taking NYC taxi data, writing it. Save as table is a command. You get used to these commands slowly. And Naina is storing this data in an Explore database with a table name NYC taxi data. You're going to run this. So, yeah, it might take some time to save. Maybe data is big or it is a small computer. So let it run. I want everyone to do this. So create multiple databases and check if this database exists. Then you're saving it. So, Lahari, we haven't transformed anything. We just read and saving it as a table. It means I extract it by reading it from somewhere, which I know, or somebody placed it. I extracted it. I didn't do any transformation. I just read and writing it. So I'm doing in the ETL, I am doing E extract. T, I'm not doing it right now. L part is loading it. Loading it in the sense I'm saving it. Earlier in the syntax, there is a word called load. Don't get confused. That load is just reading load. Here, in the ETL, the word load means you are saving it. You are saving it. So
Okay.
please don't get confused with that. Spark.read, that one load is not really saving it. You are reading it. That loading is different. Loading is reading load, that one. But here, save as table is literally you are loading it to it. So let it run. Then what we do, Lahari? We know that table exists we'll go and see in the catalog if that table exists or not. Then we'll query this table, explore.nyc taxi data table. We query that. So that gives a good hang of it, and Harun will take over and show you more structured way. This is just to make sure you get the hang of it. Subhashini, any question here? Any question here? We haven't done anything. Simple thing we did, just to get the sense of it.
No questions, Srini. I could understand this coding part.
Excellent. I think you might have already, since some videos also, you might know this already.
Yeah, Python I just recently learned, so yeah, I could understand the.
Excellent. We'll go steadily. We'll go step and step. Razu, Sai, Vishrat. It doesn't make sense.
Yes.
Right?
Yes. Yes.
Excellent. I think that is a little bigger and it's a small community edition. I think it's taking time. So meanwhile, you can go to another cell, Naina, just to prepare ahead so that a team will, Arun will start getting ready for the next one. So put another cell, just you're exploring the data. It's a simple SQL. So the moment you put percentage SQL, it means that cell becomes a SQL cell. So percentage SQL select star from explore. Once the prior cell completes, you will run this particular. This is complete.
Yes, sir.
Okay, awesome, good job. You can go and see if the in the Explorer. See that? New Extrata. Click that. You can click that. There, it opened up a browser, another browser. You see here? It I think, yeah, it is opening up. See here? It says details. When it is created, what are the columns? What is the sample data? Harun will review this more, but can you go back to your notebook? Click Databricks logo. Click, you get there. You see here? Yeah, recents. Click that again. Okay. Come back. Come back to your okay. Run your select. Run your select. Run your select. See here, simple. Your select, you are able to see. So Larry, what we did simple. We read from that particular file folder, and we actually use that Spark command, read it, then created a schema, then we wrote it here, then went and checked with SQL how this particular data looks like. So there is one command where you can navigate to that folders called DB utilities, Larry. Let me give you that so that you can run this. So you just run simple DB utils. Give me 1 second. Everyone run this. Then Harun will take over next steps. Okay. Run in another cell. Display DB utils FSLS. Yeah, Naina, can you run this?
Yes, sir.
So your DB utilities is the Databricks utilities. FS is a file system. LS is a general Unix command. That is a root. So, and you are displaying that. It displays in the structure. Lahari, do you see that? Do you see
Yes.
there is a path? This one, it has a name, it has a size. And you can further get inside of it, instead of root, just like your Unix commands, you can do it. If you don't display, it will show a different format. But Harun will help you about this command more after some time. Does it make sense? At least to start, Hitesh, Vishrut? Does it make sense?
Yeah.
Okay. Excellent. Any question, Shiva? Anything to add on this?
No, I think this is good, Srini. I think to get the hang of it, and then we need to explore the DB utils file system. So yeah.
Correct. Razu, you got a little bit hang of it. Sai,
Yes, sir.
Sai, Hitesh, Vishrut.
Yes, sir.
Okay. Naina, how do you feel as you're doing it? You feel
It's good, sir. While doing it, I feel like we can do it.
okay? Awesome. That feeling is very important for us. Super awesome. Harun, sir, is there anything you want to comment and take it forward?
Yeah, I think we're good. It's a nice start. They're getting a good hang of where to start and what it is. Yeah, I will take over just a bit. We will just reinforce what we have learned and then showcase end-to-end what reading the file is, what ETL is, and
Yeah.
then we will get started from there.
Super awesome. Next week, there will be more rigorous, but the very first basic steps are important. That's why I want to make sure everyone do this. Excellent, guys. Good job, Naina. You can stop sharing.
Okay, sir.
Yeah, good job. So if you see that, you will be always knowing where the files are. Somebody will tell you, hey, our sales files are here. It may be ADLS, it may be S3, it may be DBFS, it may be HDFS. Some location will be there, always. Somebody will tell. So always you will know. So in some circumstances, you might have to read from the database directly. In the sense, you have to get into the database directly. Okay. But most of the cases, Lahari, you will know where are the files. But please note, those are raw files. Raw files. Raw files means just raw data that you got. So your ETL work is mostly involved. You extract. Extract means you're reading it. Then after that, you may be able to transform. It means you may add some columns, you may remove some columns, you may turn some data types differently. So you can able to do in Spark. We didn't do this today. We just read. Then the third part, ETL. Always remember, ETL is read, extract, transform. Second step. Third is loading. Loading means where I am saving it. Am I saving it as a table? Am I saving it as a files? Depending on the situation. Most of the time, you'll be saving as tables. You'll save tables. Larry, the question is whenever you are saving as a table, where, which database I'm sharing, right? Eh, The tables don't isolate, you don't throw the tables here and there. You structure into a database, sales database, explore database, marketing database, like that. These are marketing tables. So share in the marketing table, marketing database, marketing dot, that whatever the database dot table, database dot table. Super awesome. You extracted, and right now we didn't do transformation. You load it. So you're managing the data already. You're managing the data. Since the data is available in the marketing database as a table, they can, business can go and SQL that, or they can use some tools to access that. So, but you are checking. You need to do some unit testing. Oh, okay, is my table is available? Is my data is available? Like that. So you already started getting the hang of it. So Databricks is so powerful. With few commands, you can handle powerful data. Even this data can be big, Larry. Even if it is 10 gig data, 100 gig data, but still it's a one line of command. It will do the heavy lifting. Only thing is the cluster size will be bigger. Instead of one node cluster, you may have a 5 node cluster, or you may have 10 node cluster, or there is a concept called serverless. Serverless means you don't care how many machines are there. Databricks will take care of, based on the load. It builds the cluster for you. It builds the server for you. That's why they call it serverless. Make sense? Make sense, Larry? Does it sound
Yes,
logical?
Srini.
Does it sound logical?
Yes.
Awesome. Harun, you ready?
Yeah, yes, Srini.
Okay.
Yeah.
Awesome. Good job, guys. Good job.
All
Good
right,
teamwork.
great. Yeah, thank you, Srini. It was great introduction. I think everybody is comfortable with the environment. And logging in and getting into the Databricks notebook, that's amazing. First steps.
You're appreciating me, Harun?
Yes, absolutely.
Okay. Thank you. Okay. Good job. Okay.
Why not? Why not? We
Eh,
should appreciate that.
Everyone needs encouragement, guys. Encourage each other.
Absolutely.
Awesome. Everyone needs encouragement. Be encouraged always. Use the words. You're not giving many money. Hey, say good job, or hey, this is nice. Use positive words. Spread the positive energy, guys. Right?
Absolutely.
Giving money is very difficult, but giving smile, giving encouraging comment is very helpful. Be more liberal on that. Some people, it's very hard to say, use the a good job.
Good job.
To say that,
Naina did a good job, actually.
what is that?
Naina did a very good job today.
Okay, good job. Okay, guys.
Thank you.
All right.
Thank you, Arun.
All right.
Awesome.
Yeah, let me also do some good job today. Because I couldn't do yesterday.
We'll say, yeah, whether you've done good job or not. You cannot
I'll try to do a good job.
self do that. Okay, but Shiva did a good job hovering all this thing. He gave a good tips. Shiva,
Absolutely.
good job.
Thank you, Shiva.
Yeah, thanks.
Yeah.
Yeah.
All right. So you can see my screen?
Yeah, Harun. Yeah.
Yes.
Okay. All right, great. So guys, please let me know if anytime if you cannot see my screen or can't hear me, just ping me. Sorry for the miscommunication yesterday. I thought I was still on, and it is very embarrassing that I was still doing my demo and I didn't realize I was disconnected. But anyways, so coming back to this, you guys now have a very good understanding of ETL and data processing. Like we were looking at this yesterday. I don't know how far I was there with you guys, but I just want to do a recap of this now that you understand the file system and the Databricks notebook here. So this is what we were trying to do as a ETL process, right? On the left, you have sources, basically data, where it is coming in. So ingestion, what we call data ingestion. You have files, it can be databases, it can be streaming, it can be, any multiple formats that it can come in. So the format can be, the files can be audio, video, text, JSON, CSV, Parquet, whatever it is, or databases, SQL Server, MySQL, DB2, whatever data, Oracle, whatever databases you have here. Streaming, again, any tools that they are streaming in can be IoT data, can be log data, logs that is streaming, Kafka, or any other streaming things. But you can also stream files. Even the files also you can read as a streaming data. Log records you can read as streaming data. So then we see this is called a medallion architecture that we talk about, the medals that you get, gold, silver, and bronze. From left to right, it shows how we are reading, loading, transforming, enriching the data, and then making ready for the aggregated data, ready for the consumption. Okay, so bronze is as close to the left as possible. You just take and ingest the raw data. Silver is where you do transformations, like you check your data quality, null values, or split the strings, or invalid data types, incompatible data types coming in. Split the columns or merge the columns, join the tables, whatever you do. You enrich the data and then write the silver here. So it has more data quality than the left. Okay, it can have the same amount of data or less data, but it has more enriched quality of the data here. Then we come with the gold is generally aggregates. You see here, it's aggregates. It's like you do group bys, you do joins again from silver, and then group by, and you're specifically trying to answer something or making a data set ready for a specific purpose. Most of the times the purpose, or maybe in generic. So for example, you're running a marketing campaign, okay, and then you have to provide customer data. Let's say I'm running only for a geography. So I want to run only for Dallas or Texas residents. So you're taking the data of the customers and then making sure you take a subset of that data. So you filter where, state is Texas, city is Dallas, or you put some zip codes in there, and then you see whether I want to target only the income group greater than this, or the family size is greater than this, whatever, all of that inputs you take, you apply those business rules or transformations, and then you make aggregates, and then create some kind of a subset data or a materialistic view or a view of data set here, and then that will be consumed by the downstream systems. Whoever is, let's say you have a CRM system, Cbill, or whatever system that wants to read and then do a campaign on top of that. Or it can be reporting dashboard or BI tool like Tableau that you want to read from here, and then show the report of sales of particular territory. So I want to look at all the sales for each month in the US territory, right? So what you do, you group by the entire sales data by each state and then by each month. And then you keep it ready here so that every time you want to check that, you don't have to run the query and then do the aggregates every time. So you run it and make pre-aggregated, pre-processed data here ready for consumption so that it is faster and easier access to consume this data for the BI. So that's in a nutshell, at a very high level, how you organize your ETL, which will actually translate into your data pipelines that you do. So most of the industry, when you do go in as a data engineer, I think I know most of you are here, correct me or add more if you want to, is that when you write a data pipeline, it's more or less like, okay, we are getting this data from here, and then we want to do and process and get everything ready for here for the BI to consume and show it in the dashboard. That's most common use case that we have in the data engineering space, right? Are you guys with me? Any questions, comments here? You want to add anything?
So far, no. Thank you.
Good. All right. So this is what I'm going to show you. So basically, as we are talking about, let's say the sources, right? So sources can be anywhere. That's what I said. Now we talked about type of sources, right? We talked about files. What are different formats of files again? Structured, unstructured, whatever. What are the various sources, databases, file streaming? But locations, it can be anywhere. So where is your source? For example, database. Let's say I have an Oracle database, but the location would be somewhere. Let's say you have an Oracle database installed on this host port. Everything will be there. Just like how you access your SQL client to connect to the database, the same credentials you take and then go read the data from those database tables, right? Same thing, files can be anywhere. They will have some Unix location or a server host location and the folder location to read from. But since we are talking specifically here about Azure Databricks, right? So when you have any of the underlying cloud storage, so basically mostly the files come in, they come into any of the cloud storage, right? So the sources will push in there. So if it is Azure Databricks, where does the files come in? Where is the data storage for Azure? Anybody?
ADLS?
Yeah, right. Sure. So exactly. So the files would be in the ADLS because that is the storage layer for Azure. And everybody know that, right? So if not, just look up the cloud storage. So it's a Azure Data Lake Storage, we call, right? ADLS. If it is AWS, then you know it is S3. Okay, simple storage service, S3 we call. That's where all your files or all your data is stored in AWS. In Azure, it is ADLS. So you kind of connect there and read and write the data from there. Now, even here, when we are I'm trying to showcase something. So I'm trying to read something called a movies.csv file. Okay. Now, what we said, we are reading it from the DBFS. Just now we looked at DBFS. It has something called dbutils dot file system dot list. Okay, so these are the commands. So you can look up what are the commands in the dbutils file system. So ls is the list. Okay, so we are listing, just like, see, you have Unix. You are listing the files. What are the files there in this path? This is the Databricks file system, DBFS. So DBFS is just a layer on top of your storage. So because you're building this on Azure, so it will be a layer on the ADLS. It is managing. Internally, it is storing in ADLS, but it's managing, it's mounting that as a file path for you to manage in DBFS so that you don't have to directly go to ADLS and read and write from here. So for now, just say in DBFS, this is the path. Okay. And then you want to read the file. So what is the file? What are the files available? So this is all I have loaded in this path. Okay. These are all Amazon files. So about 157 files or folders available here. Okay. So if you see here towards the end, there is something called movies.csv. So this is the file I have loaded. And there is something called movies lens. So this is a folder, right? So now if I want to see what is there in this movies.lens, I can go and just say dbutils dot file system dot list and then I will give the path. Okay. So you will get all of this. File info path. In the movie lens, you have a readme file. You have links.csv, movies.csv, ratings.csv, tags.csv, and then this is the size and this is the modification. Since this is not very readable, we use a utility or command from Databricks called display. So we give everything to this display, all this input, so that it will just neatly structure and format for us to read. Basically it will split like, path is this, name is this, size and modification. So don't confuse why we are using display, why you're using DB utils. It's just formatting. Okay, display is like print statements or format statement for Databricks. This is a Databricks command to format and give it in a proper structure. Right? Now you understand where this is. So how did these files go here, land here? So I will show you because if you want to just practice this, there's a hack how you do this. Get here. So go to catalog. Okay. Here, catalog. There will be something called create table. So don't worry about any of this. Go to create table. Now you will get this upload file here. Okay. Now you go and make your own folder. So this is kind of a root folder. You cannot change this file store / tables. So there is a root folder. So here you can create your own folder. Okay. So I can say Harun. You can put and just say Harun. Okay. And go here, drop files to upload or click to browse. So this will give you your local computer where you can just upload from your local system. Okay. So you can go here and then upload any of the any of your files. Can be CSV, you can upload folders, you can upload CSV files or whatever you can do here. And that's it, done, leave it. So if you want to click any of this, you can do this, but this is extension. So once you want to use this file and then create a table or UI, so that is what you have to do it there. But just go here, select your .csv file. Let's say if I want to do movies.csv. So movies.csv is here. I go and upload. That's it. Movies.csv is now uploaded to this folder. Okay. Now go back. This is done. You don't need to do anything. Go back here. And remember, this is all we are doing just for our practice sake. In actual production or real time, all this, you will get a location where the files are coming in, the source files. Okay. So you go here, tables / Harun. So here, see, there is one PNG file, there is one movies.csv file. 2 files I have uploaded. You can use this or you can use this. So this is the movie lens folder. Within that, you have these files. Okay. Now you're clear about how you add the files. Now I can also see what is the content of those files, but we will come to that later. But now see, let's see. I have a file location. I have a file type. Now I'm going to read that file here. Spark.read.format. Format is CSV. I'm reading. And location is file location I have given. And there are some options that I have provided here. What these options says is infer schema is true, which means what is the data type? You scan the file, look at the data, and then you make a assumption, okay, or guess looking at the data, what is the data type. So it will automatically give you it will infer what is the data type. If it cannot, then it will just make it string. Okay. if there are only null values, and if it cannot, so it will give string. Then option separator is delimiter. Header, whether your header is having a first row is having a header column or not. So if you look at this file, what I'm doing, this is the same movies.csv. So it has a header, movie ID, title, and genres. The first line is a header. So I want Spark, when it is reading the file, to take this header and make this the column names. So that's why when I give this option, I have suggested infer the schema and consider the first row as header. Header is true. So it's not first row as header. It's just say, I will just make say has header true. Okay. So header is true. So then it will take first line as header, and then it will try to create sequence. Then once you read this, once the Spark job reads the file, it will give you an object called data frame. Now, what is a data frame? We will talk about it, but for now, just consider it as a table. Just like when you do a select star from table, it will give results in a tabular format, right? So data frame for now is like your data with schema. In the sense, you will have columns and the data in that. So then I'm going to display the movies.tf. So I'm just reading and displaying here. So now it is reading the job, reading the file, and then it is displaying the data. So there are about 9,742 rows in that. And then if you can see movie ID, title, and genres, all three columns and the data in this. Okay. Now, what is the data? So what is the data type? It has automatically inferred movie ID as integer looking at the data. I have not, if you see here, I have not told anything about whether it is a number or string or whatever. It has automatically taken from that. There is a title. It's taken string. It knows because it has all strings, and genres, it has also taken as a string. Now, if you see, there is some number added to the title, which is, we see that the data is coming in as release year. And then you see genres are multiple separated by the pipe symbol. Okay. In the real world also, the requirements they will send you, hey, we are sending the description title. The year is also embedded into the title, which is within the brackets and the last. Now they will give you the last 4 characters within the brackets is your year. You have to extract that information. We are not giving you separately. So sometimes they give you separately, like, split the string and then give you year separately, but here it is not. So that is exactly the kind of transformations that we talk about, enriching the data. One of the transformation is title should be title. It should not have the year in the title, right? So title should have only the title, and then year should be separate. Let's say release year or whatever. It should have a separate column. And that is what we are going to do in the transformations when we transform the data or enrich the data with the data quality. Genres, there are multiple genres here. Now, if I want to say, hey, how many movies are there in the children genre? If I want to answer that question, for example, this data is not very convenient because I cannot go and say, hey, select where genre is children, because it is embedded into this, right? Can we do that?
No.
No. So probably we can do like, where genre like percent, children percent, something. So wherever it has a children in the genre, but that's not very clean or neat way of doing that. So what we can do, we can split or make this movie, Jumanji, into 3 rows, each with a separate genre. We can explode that and say, hey, Jumanji can be put into 3 genres, 3 multiple records with 3 genres. In that case, when I take children, it will have 1 row with Jumanji and children. And then all other children movies also will come there, like Tom and Huck. So all of that will come when I say children. Adventure, again, it will come, and some other movie will come in adventure. So something like that. So I'm just giving you an example of what kind of transformations, what do you mean by transformations or enriching the data, that you are making it closer to the analytics. Good. Okay. So this is what I have read the data. Now, instead of again, so be very mindful. I'm just running you through all of this as an overview at 30,000 feet at high level. We will revisit this multiple times so that everybody is comfortable. This is the foundation of whatever you learn. Reading the file, processing it, transforming it, writing transformations, doing aggregations, and writing to the tables at each level. So that's kind of bread and butter for a data engineer. So all of you have to be very comfortable doing this. So that's why we'll walk through once end to end. Then we will come back, revisit, and dig deeper into at each step what we are going to do. So now, as I said here, I said infer schema, I left it to the Spark job to figure out what is the data types based on the data. But that's not a good practice. It is always best to give the schema for you to define the schema upfront so that you can enforce the data quality. Okay, remember this is also, when you do certification, these type of questions come in about the inferring the schema. It is always best to provide a schema to enforce so that the data quality is better. Now I have given you define the fields with struct type, struct field with movie ID, title, genre, and then what is the data type. So these are all come from Python. If you see here, PySpark, SQL types. So what are all the types here? And then true is whether it can be null or not. So we put it nullable true. So this structure schema, now I can read the same file. So this is just another way of reading the file. You can read it like this, or you can read it like this. So there are multiple ways of reading the file: .format, .option, .load. Here, I'm just directly saying read.csv. Instead of giving it as a format, I can directly read.csv. It notes, okay, I'm reading a CSV file, is already a location. Separator, I'm giving comma. Header, I'm giving true. Schema, I'm giving as my schema. So this is the schema that I'm defining. The data frame, and again, I go and do a display data frame. It's the same thing. So you get the same result. Basically, we are not changing anything. We're just showing a different way of reading the same file. But this time we are enforcing the schema here. Once that is done, so how we are going to write. So medallion architecture, we talked about bronze, silver, gold. So we define those databases. Let me see if we have already defined that. If we have created that. No. So if you see here in the databases, there is only default. There is no other database because so whenever the cluster is retired or when it is destroyed, because this is a community edition, you will lose those databases. You can still again go back and create those databases. So I go here and then I use this as SQL. See here. So all of these are Python we are using. Okay, this is Python cell. We are using Python here. We are using Python here. Here you are using SQL. So go here and say %SQL and then use create database. So I'm creating 3 databases: bronze, silver, and gold. Run this. Now go back. Go to catalog. Now you can see bronze, gold, silver, 3 databases. There are no tables yet in any of these databases. Okay. Now come back. databases are done. Now I'm defining a table called bronze.movies. So bronze is my database, movies is my table name. Now I'm going to write the data that I have read from the file. Which file we have read? Naina, which file we have read? Which file are we reading now?
Movies.
Movies. Okay. So yeah. So we are reading movies. So I just wanted to create a table called movies and put it. So I have not explicitly creating the table here, but when I save it, it will automatically create the table if the table does not exist. So movies data, remember where in which field that we have taken the movies data? It's called movies underscore df, right? So this is where we have read the data, movies underscore df, right? Raju?
Yes,
So this is what we have to write to database.
it's a
For
data
movies?
frame, right? You need to write.
Yes. So what we will do, we will take this data frame, say dot write, again same dot format. So there's a simple change in the syntax. When you read file, you start with Spark because you need Spark job to read. Spark dot read. When you want to write, you don't say Spark dot write. You say what is the data that you have to write. Data frame dot write. So it will automatically use anyway Spark job to write that because the data frame is built on the using that Spark context or Spark job. So data frame dot write dot format delta. Again, we are providing, so by default it's delta format, but you can also write as a file, as a format too. You can write back as a Parquet file or JSON file, whatever. You can still write it into a different file format as well. Mode is overwrite. So you can use overwrite. You can use append, where you're just adding the data. Overwrite is you are overwriting the existing data. And then when you go into more dig deeper, and then you can do upsert. There is a merge statement that you can use to write, where you insert based on the keys. If it is not there or if it is already existing, you update, and then you can write which columns you want to update and all of that. So that is a different, but for here, you can also check the documentation, what are different modes available. The first one is here we have is overwrite or append you can use. So I'm using overwrite. Save as table. So I'm going to save it as table. And the table name is this. Bronze.movies, just a string. You just give it as a string. You can just comment this out and give the string name here also. It can also work. So I'll just go there and then save the data. So it triggers Spark jobs to write the data into the table. So you see all of these are multiple jobs that are running with different stages to write it to the table. Okay. Now it is done. So we will also go through this when we talk about Spark internals. What is the job? What are the stages? What are the tasks? How it is using it to write? All of that we will read when we get into the internals, Spark internals. Advance that, dig deeper into that step. Now we have written the table here. You can go back, go to the catalog, go to bronze. See, you can see the table here now, movies. Click on that. You can also see a schema. Just do a refresh. Okay, now you can see the schema and you can see the sample data. Okay, now that we have created the table, we can go and query the table just like you do in any SQL editor. Or says %SQL, select star from bronze.movies will get you the data. Okay, 9,742 rows. If you go here, 9,742 rows. There's one header. If you remove the header, it is 9,742 rows, right? So we are good. We are sure we got all the data loaded into the bronze table, right? Any questions, comments till here, guys? Are you good? You got what we are trying to do? Hitesh?
Yes, yes.
Rashmi?
So we just we converted movies.csv into a data frame using Spark to read, and then loaded into a database, bronze database, with a table name bronze.movies.
Yeah, that's right.
Okay.
Okay, all right, good. So now if you look at it, the first in this, we from here to here is done. Okay, from this part to this part. Now let's move into the silver. So we are at time. We will quickly wrap this up. Anyways, we are going to redo this, revisit this multiple times. So then we are going into the silver. And one more thing, yes, you can also register the data frame as a temporary view in the memory so that you don't have to write to the table and then again read back from the table. You can within the memory, in the memory itself, you can just register the data frame as a view, and then you can do a queries on that view as if it exists as a table, though it is not physically there in the created or written into the table yet, but in the memory you can still refer to it as a table and then do all SQL operations that you want to do like this. We will also explore that. Now, so what we are doing here, say filter, what we can do on the data frame, you can do a filter where movie ID is greater than 100. So if you see here in the response, in the result, you get all movie IDs where ID is greater than 101. And then you are selecting movie ID and title. Genre we are not selecting. So it's like a SQL statement where you are saying select movie ID, comma title from the table where movie ID is greater than 100. That's what it correlates to when you want to correlate it into the SQL, in the SQL world. And in the PySpark using the data frame, that is how you represent that same operation. Or you call this as a transformation. What we are transferring, filter is a transformation. And select is a transformation. We are transforming the data set from this to this, where we have less data and then we have less columns. So that is, say, some transformation. And then, so as I said, select movie ID title from movies where movie ID greater than 100. It's the same thing. That's how you represent using SQL. So this is another table. We don't want to do this right now. We can do this later in the joins, but we want. Okay, let me run this. So there is another table, another file, ratings, which has ratings of those particular movies. Okay, and then I'm reading the same ratings CSV file with the path, same options, and it's called ratings data frame. It has user ID, movie ID, rating, and timestamp here. 10,000 plus rows because each user can give multiple ratings for different movies. So there will be more than one row for each movie. And then there will be more than one row for each user. One user can give ratings for multiple movies, and one movie can get ratings from multiple users, right? So it will have more data in general. So you also can do ratings here. Now, if you see joining two tables using the data frames, or we are joining two data frames, just like joining two tables, we can join two data frames. Movies data frame, joining with ratings. The key column is movie ID. Okay. And then we are selecting these 5 columns. And these see the transformations here, what we are doing. With column renamed. So this is another transformation. Select is one transformation. Filter is one transformation. Column renaming is another transformation that we are doing. Title, we are changing the column name from title to movie name. With column is another transformation. We are adding a column here. Okay. So this column does not exist, but we are adding a new column called language. And we are just filling it up with default data called English. Okay. And then doing filter here. Ratings data frame. Ratings data frame of user ID. So where we are saying here is join this and this, select these columns, column rename, add a column, and then filtering where user ID equal to 1. And see, there is an and here. So, and movies data frame equal and movie ID equal to 1. So basically we get one row where movie ID equal to 1 because we have filtered here movie ID equal to 1, user ID equal to 1. This is what we have filtered here, user ID equal to 1. And then select 1, 2, 3, 4, 5 columns. So we have selected 1, 2, 3, 4, 5 columns. And then see, we have added another column, language. So that's why we get 6th column called language. We have filled it up with default value called English. So we get English here, right? And then we get all of this movie ID, movie name, genres, all the data. So these are all the transformations. Look at this. We have, this is called chaining. Okay. We have chained all the transformations in one line. So join is a transformation where we are joining two data sets. Select is a transformation where we are selecting a subset of the columns from both the columns. Renaming a column, name, adding a new column, and filtering the two columns, with an AND condition. So when you do this in a SQL, what does it look like? Anybody want to try this in a SQL? Who wants to give me the SQL for this? Let's try. Okay, let me call.
We can start with the select.
Vishrit, you want to try this?
Sure. So select movie ID.
Okay, let's say we do select first. Okay. What happened? Okay, select.
Then the column
Select
names
we
would
are
be
saying, right? So select we are saying we are selecting these columns. Okay. So we'll say movie ID.
and then title as movie name.
Title. Okay, we'll come there. Okay, we want to do one at a time so that you don't get confused. Rating, comma, user ID. Okay, we'll say from. Let's say movies DF is a table. Okay, let's say I'm just giving you. Don't take this literally. The SQL. I'm just giving you. This may not run, but I'm just do the structure. Then we say we are joining with ratings. Okay, let's say I have a ratings table.
On.
So what did we cover? We covered the join. We covered the select. We are joining with ratings. Now we have to say on what we are joining. Now let's say on. Let's say movies table I call M, ratings table I call R. Right, and then we say M dot
movie ID.
Movie ID equal to R dot movie ID. Right. So this is the join is done.
Yeah.
Select is done. Okay. And this on condition is done. Now with column renamed. So what are we renaming? Title to
movie name.
Movie name. So here when we are selecting, we say as movie name. So that is our column rename. Now we are adding a new column, right? With column language, comma. So what we say here, we add English as
Language.
language.
I think
Okay.
it's a keyword.
Yeah, it's a keyword. Yeah, maybe. Let's say whatever. Now that's done. Everything.
And then
Now
filter.
this is the filter. So filter is just writing where clause. So where I say user ID is from ratings table. So I will say where user ID equal to 1 and
Movie ID.
movie ID equal to
M dot movie ID.
yeah. Okay. So that's how you kind of correlate it with the SQL. And the same thing you do the transformation. Okay. And then if you run this, you get transformed data frame once you join those two, and then you get all of this movie ID, name, genres, rating, user ID. So here, if you see, we are also doing a transformation for release year. What we are doing, we are taking a substring from movie name. So this is the syntax. Don't worry about this. What we are getting is just getting those 4 characters from the brackets out as a separate column 1995, so that we can directly do any analytics, count star where release year equal to 1995. So we can do like this. Okay. So that's the transformations. And we do this. Okay. So that is all. So I wanted to cover this today. Once you do this, you can write into the same thing as a silver and table. So you're right here into silver.movies final. Here you can write into the table, and then you can do the aggregations group by real release year int. And then you can just write it the same thing to the gold movies by year. So in the gold, you will have each year how many movies were created. Okay. I will share this demo notebook. I will share the video. Just go through it, but don't worry too much about it, because we will, as I said, revisit and go step by step.
Okay.
Okay. All right, guys. I think we are at time. We're more than 10 minutes. So I think that's all I had to share. You can see everything that is created here. We'll get data. Just follow this, and then we will see here. You get count, release year. Okay.
Yeah.
If you have any questions, ping me. I will create a document, and then share these links there in the WhatsApp group, our group. So you can go through it and ping me if you have any questions. Otherwise, we'll meet next week. All right. Thank you. Have a good day. Have a good weekend, guys. Take care.
All right. Thank you, everyone.
Thank you, guys. Yeah, bye.
Thank you.